Thank you. So, it's the finish now. Good to see that all of you have stayed here. I'll get started with the news on VTest Studio and our test design tool. I thought that we best proceed in such a way that I will then show a typical workflow of a test designer, and I'm trying to show you where he gets past new things. So test implementation in Test Studio with the previous test design editors, it still is possible, fast and easy and simple. Now what's new? We've now got ribbons, so it's going to be even more efficient. So you've got here some semantic. No, it doesn't work. I could have learned this. Others tried it before me. So you've got ribbons grouped according to semantics like traceability, documentation. You've got specific ribbons like for the test table, graphical editors, different design editors. So hopefully you will find the nice functionalities that you've implemented for you. We hope that you find them even more quickly. So the test designer has implemented the first part in the test table, and now he says, wow, we've got something, I want to do that in C#, might be a bigger thing, many classes, many arrows, I want to group them according to namespaces. So the refactoring features of the Visual Studio is something that I want to use. Now what he does now is to say, add test unit, Visual Studio project. And here we go. This exactly is new. In the Test Studio, you can make a direct reference there to the Visual Test Studio. So instead of getting connected in the Test Studio, you can now do that in a Visual Studio project. By way of a double click, you find your way easily to get there. And you've got all opportunities that you've got also in the VTest Studio. You've got access to signals. We've got type libraries for access to parameters. You can have access to variants. You can define test cases, and so on and so forth. Even before, you were able to implement in the Visual Studio, but with some limitations. Now we've got full access to all of the features, and we take care and make sure that as soon as you want to make a change in the VTest Studio, new parameters, for example, it's available in the Visual Studio. As soon as you trigger a compile, you've got the changes available in the VTest Studio. Good. Our test designer now is through with the test design, and he says, before I execute it, I rather ask a colleague to review it, but I would like to document that. All the things that I've already reviewed, what's the status of my test cases. Then he says, okay, I want to attach an attribute lifecycle to each of the test cases, and I want to make a comment, a reference to that. And this is also new. Just any metadata of test cases can be defined, and they can be played back into test management, and that will later on be available in report management. So life cycle, you say it's an enumeration, it's submitted, invitation ready for review and reviewed, default value has been determined, and some reference if necessary, then add a string. And if you define that here, then for each of the test case that you've got defined there in the graphics, you've got the test case attributes available. And now you can get the review started with a colleague and work your way through test case after test case and say, well, this is quite fitting. Review has taken place. Next test case. Wait a minute, something unclear yet. That's still in implementation, being implemented, and thus you can nicely document all the things that you've looked at together with your colleagues. Or another example is that you document the ASIL level in a test case or the attributes. You're perfectly free to do whatever you want. In a review, it may be necessary you come by a reusable function, and you also want to review the content of the function. Then you say, okay, go to definition, review the content of the function, and now, of course, you want to go back to where you were earlier in order to continue your activity, and this exactly is now also possible very easily. Navigate forward, backward within VTest Studio. All of a sudden, you're right where you came from. Then at some point in time we are through with our review. The test designer says, before we go to execution, let's have an overview of our test case. Have I actually reviewed all of them? What's my status? And then he opens the test case overview. You've got a new view there in the VTest Studio, which gives you an overview of all the test cases implemented in the test unit, both as a table or also graphically, with the appropriate overview, for example, on variant dependencies or the attribute values. The attribute values can be changed by you. Also, they can be set for many test cases simultaneously. You can filter accordingly and so on and so forth. What you also can do with this view is that you can assign trace items to test cases. So if the test designer did neglect then traceability, he can catch up with that, drag and drop from the case item explorer, either one trace item per test case, or also several trace items for one test case, or you can also say I've got several test cases and I want to link them up with one or n trace items, and then you can very efficiently do that in this view, and you don't have to click your way through the individual test cases in the test design editor. From this view now, you can very simply move on and navigate to the test design editor by way of a simple double click. That brings you to the appropriate place in the test table editor and the graphics. So you may want to crisscross several times, and it may be helpful then to do that on two monitors. On the left you see the test case view, on the right hand the test editor. This wasn't possible in the past. Mr. Küssner is happy obviously about this. So the documents can also be distributed onto several monitors. Then at some point in time we are finished with that. We go forward with the execution, everything as before. The executable test unit is built, you configure it in GNU, and you make the tests there. So you wonder, what's new about this? Looks like before. Quite right. Not much of a change. It only gets exciting when we take a look at the report. We have seen the attributes that we have defined for the test cases. Based on the attributes in the report for certain test cases, we want to find them again, saying show me the test cases that haven't been reviewed. I will leave them out, and now if you define your query, then you can say show me all test cases, and then now immediately I can query my attributes. Give me all of the test cases that have the life cycle and implementation, and maybe a note that is not empty. If we then execute this query, we get exactly those two test cases for which this comes true, and then of course we've got the attribute values also available in the report. What is more interesting, however, is maybe not those test cases that haven't been reviewed yet, but the failed test cases. If I then execute the query, show me all failed test cases. In this instance, I find just one. I've got a failed test command. Major question is, why is that? Do I have an error in the test link, or is it an error in the test? So I can easily find it out. So from a failed command, we can go directly into GNU or VT Studio. We can navigate directly now. If I say jump to GNU, to that point, to that spot, then that brings me to the appropriate timestamp in test trace. And if I know the feature of the global window synchronization, I can simply analyze what was going on there, because all of the windows, graphic windows, state trackers, and so on, they then scroll towards this timestamp. If I happen to notice, well, it was a mistake in my test design after stimulation, I just didn't wait long enough until I did my testing, then I say open test design, and all of a sudden I jump within text design to the appropriate spot, and I can increase my waiting time, for example. This is how the cycle is completed. test design very briefly. Let me try to summarize. What have we seen? What are the new features? We've got the ribbons. We've got the dedicated connection to Visual Studio. We've got the test case attributes, navigation forward, backward in VT Studio. And that's true for all design editors and across the limits of data there. If you say go to parameters, then you will go back to where you came from. We've got our test case overview, the multi-monitor support, the queries in the report viewer for attributes, navigation from report viewer to Canoe and VTest Studio, and navigation from Canoe to the test studio. That much about the news. Now some brief outlook. What are we busy working on? Let me pick out 3 topics in this context. First of all, additional parameter types. In the future, interface functions, or there will be messages, nodes, and networks as input parameters for interface functions. You can define reusable functions and test cases, and you put a message in there. And this function, just as well as the CAPL and C# functions, can then be called in test tables or the graphic functions and the graphical editors. In order to round it off, we also need this feature in parameter files. In the future, you will have the opportunity of defining test vectors. That is, for example, a test vector that consists of a message and the max occurrence count, and then you use this test vector in order to parameterize the reusable test case, and you get one call of check occurrence count. What is it called? Check message occurrence for each of these messages. We stick to the test case lists. Even today, there is the opportunity to assign trace items to test case lists. They are propagated down to individual calls. In the future, it will be possible to configure trace items for individual calls, either directly in the test table editor. So per line that you are defining test table call, you connect one or several trace items, or then we want to separate data from the test sequence, then you do it directly in the parameter file and you attach the trace items to the appropriate test vector. We dwell upon and stick to traceability, automatic test control and test campaigns. What is hiding behind that? We've already seen this picture in a similar way. Somebody did some stealing there. Most of you will know that. We can already do that today. For the bigger TDM systems, it's a standard. For the other ones at random, it can be implemented through our Exchange formats. We import requirements or test case specifications as trace items into VTest Studio. We link them up with test cases. We play the information back to the CDM system, and after execution of the test unit, we play the results back. So far, so good. There's some additional room left in that diagram for this case. What we want to support in the future is that test execution of Canoe directly from test management systems can be supported, and based upon that, the selection of test cases to be executed based on most different criteria, be it for all test cases from the requirements that are linked to specific requirements like ACE level D, or execute all test cases which with verdict failed in the last execution cycle, or test cases assigned to a specific defect in a defect tracking tool. So we couple it up with the TDM system by automating Canoe based on what we've got available in the TDM, and then ultimately you've got the opportunity of selecting test cases at random query options of the TDM system. So everything that the TDM system allows to RQM, Polarion or PTC, so all of this can be used by you in order to ultimately execute the appropriate test cases. And here again we are planning, so it's supposed to be based on open Exchange format. So if we don't connect your system out of the box, then we're still flexible enough to realize that based on our exchange formats. And that was basically already it from my side. So let me pass on to my colleague. Thank you. So we've seen in the field of test authoring, there's all kinds of news, all kinds of new functionality and features on the execution side. We also want to encounter that. So at the end of our event today, I want to present to you the news that we have in the VT system and the things that are about to be developed that we will be releasing shortly. So it's not about new modules. In the first slide, it's about non-existing modules, functionality in GNU, for which there has been demand several times already. What do you do if you've got a test set up, if you have developed a test program with Vita Studio or directly with GNU, but you haven't got all of the modules available? And offline VT system addresses that, which has been available as of GNU 11. With that, you can execute test programs, even if the VT modules do not exist physically, all of them or parts of them. Then appropriate, we can configure it accordingly, as shown, and the models can be set offline or online and definitely run the test. The test is going to run through couple commands, feed the right answer back. Of course, if you want to have a correct verdict, you have to do justice to the fact that the non-measured value that you provide data for that's also possible with this functionality. So it closes the gap between one unit developing tests and the other one executing them. The developing unit, however, not having all the hardware available all the time. And with that feature, they can comfortably develop tests. But then there are also module news. We've got the network interface, the smaller one of them, the 6104. We've revised it. It's called 6104A now, like the predecessor module. Already it has got 4 channels, CAN, LIN, J1708, but then newly CAN-FD support, and it's also car-line capable. So that lifts things from the bottom, and the old one has expired there. Then there's the 6204, which can do VX3, but that's a smaller variant, basically, in order to be able to serve the protocols mentioned. Then we've got the option sensor. It has been released for quite some time, so we expanded it by the 2710. That can already be purchased. It's been prepared. It's being supported by GNU using all of the digital IOs. Additionally, then also the protocols UART, RS485, and LVDS in the sensor context, I have to say. So in video stereo camera, which generates gigabytes of data, well, cannot be connected. It's not intended for that, for automotive sensors. Additionally, you can use the user FPGA, which addresses the case where you've got serial protocols that are not available as a standard, but that you can implement on top. And then there is some news about the VT7900. For those who don't know it, that's a carrier for application boards, a VT insert, which enables the user to contribute their own electronics into the VT assembly. There's also a basic variant, but it's now also available with user FPGA, which then increases the options and opportunities. You can accommodate for customer-specific electronics, and additionally, onboard-specific then logics can be used to enrich it. There's a large abundance of potential opportunities, and it is already being used in some areas and opens up many new options. Now I want to talk about the things that we are currently developing that are more or less close to release. I would like to take a look at the VT system as it is, for those who don't know it. This is schematically showing what we are doing with the SUT system. So we place ourselves underneath then a system, which in the extreme case may be an entire vehicle. We place the entire system around that. We've got fault detection or a switching unit, so we can simulate, serve system input, but we can also analyze and measure and simulate. So we can work there on the outputs. We can, of course, take over control on the power supply, power control of the system under test, and as we are vector, so we can provide for the communication to network connection, including real-time PCs. So that's the setup of the VT system, and I would like to try and show you what we will be doing in the future and how and where we can find it. Let's begin with the simulation block. We've got one topic. That development is just about to be released. It's a module which simulates wheel speed sensors or then crank camshaft sensors in order to make them available in the appropriate test setup. It's in such a way that the standard types for wheel sensors as shown can be selected, and you can serve them with a module on 4 channels. So you can do it with the current and voltage module, can set the current and voltage values at random. That closes the back. Then in part we've served it with other models, but the electronics on the board is much higher performing and much better performant and closes kind of a gap in the direction of ECU testing. Then we've got a second topic, that's fault injection and switching. So we skipped one, unfortunately, on simulation. So quite a few bus protocols have already been implemented. So E2C comes at the end. We will then come forward with that as of the autumn release, and that will then make it complete. For those who don't know it, so PSI5 and Zen protocols can be served with that, and controller-prone protocols like SPI, they can also be offered. All of that has already been released. So E2C is rounding off the program, basically. But now really to fault injection and switching, there's some news as well. We developed a module which is about to be released, 2832. We call it switch matrix. So the task is in the test bench procedure that it should make freely switchable their load path, much more freely than what we can do at the moment. But also PWM type switching should be enabled. So in order to do some kinds of simulations, all of this under load, then with the high performance, not only with the signal level, but with currents up to 16 amps. So we've offered an 8x4 matrix, which can be freely routed, configured from Canoe, so that you can apply appropriate currents and connect them. You can also measure the currents, and each path then can be applied there with PWM, and the functions can be mapped rather nicely. This is something where there were many requests, and now it's available. Some information on technology. It's based on semiconductor relays, so that up to 60 volts we can switch the appropriate power levels. Then we have 2 intercoupled relays in order to run currents in both directions, so that you don't have to pay attention in terms of the order or the direction in which you are then connecting the test specimen. We hope to get it as open as we know it from other things. Then from measurement and simulation, serving the ECU outputs, we've got a minor change there. So there will be a 60 volt suitable version there, the VT1104, in order to serve 48 volt power grids. So that's basically finished. It has to be finally released only. And then we are planning for a new module for next year. That's an explicit current measurement module. Measuring current is something that we can already do, but there is still a certain gap that you may be recognizing in the motivation. With the 2816, we can measure currents on several channels in a relatively good way, but with a restricted area and with adjusted accuracy. And then with the 7000A, we can measure a broad range from individual microamps to 100 amps, but we can do that only on 2 channels, and the 2808 is supposed to close the gap. 8 current measurement channels with a reasonable, so if we don't take then anything, having a reasonable range, measurement range from 1 milliampere to 16 amps. No more is possible due to onboard reasons, and it will be able to measure voltage up to 60 volts, and it will offer detection and indication of current flow direction and determination of conducted power per channel. Then we've got the power control end. There's a small enhancement. The existing 7001 occurred in several of the slides today. It will also be lifted to the 60-volt level so that the ECU input can be made available for 48-volt power grids. Now, with regard to RTPC and bus interfaces, we've got a major topic there, Ethernet interface. There are already lots of Ethernet interfaces from Vector, but there will be a separate insert there for that now, which is functionally similar to VN5640, and then with an outlook we are also talking about a new PC module, which I would like to briefly try to present to you. Ethernet interface is designed in such a way that we've got a basic module, 2 gigabit Ethernet channels, which is the then carrier for a PIGY board, but PIGY kind of implies the wrong size. It's Euroboard format, where 6 automotive Ethernet channels each are accommodated. The first variants will be 100 base T1, so the automotive broader reach will be addressed by that, and functionally it's almost in a match with the 5640, so there will also be meter conversion. It will know that. It will also be able to perform switching. The extra that we're having, because it's a VT system with a test focus, is that a certain amount of fault injection would be added with the 6 automotive Ethernet channels. So the typical and usual relay switches will be possible there, short circuit, and for 3 of them also variable signal damping. It will be possible to include that in order to do more justice to the testing aspect. In the second line, from the beginning or middle of next year, there will be a gigabit PIGY, so that with the same carrier board, gigabit Ethernet can be served. There we have to have a different approach on fault injection. We can no longer do with relays, but we will have comparable technology, also with 6 channels. And then, so that we find a buyer for that, we will do things at the PC front. So from the VT systems, there are already models. So with the Celeron dual core and the i7, the larger ones, we are doing even more in order to be able to offer more computing power. Ethernet interface also generates a certain data volume, data amount, but number of bus channels to be served with the system. We want to improve on that. At the moment we can 16, because we've got 4 channels at 4 interfaces each. We will lift that up to 32 channels and Ethernet connectivity. Here we've got 2 ports at the moment. We will lift it up to 4 so that we can connect more Ethernet devices to the computer, and USB 3 is something that people are also asking for. That will also be made available. Well, place consumption space requirements, it won't be any thicker, so the board has already been identified, and with cooling it will remain limited to the 2 slots, so that we don't have to load the entire rack with PCs only, leaving us with no other spaces left. This is an overview again of the planned new features. It's the same topology like in the input picture, in the beginning picture, but for you to be able to assign our features to places at the execution front lines, we continue to be active everywhere. I think the portfolio is already quite good. As we've seen this morning, there are already various uses, but time and again there are some topics and issues where we can do more, which we will do, and that's the end of my presentation, and I'm looking forward to your feedback and your questions. Thank you so much. Thank you, Mrs. Katranski, Mr. Hild, for presenting the new features. Let me take a look around. There certainly must be some questions here. Isn't that possible? Don't you have this? Don't you have that? And well, we will also be available later on. Spontaneous question. Earlier we heard the presentation by Mr. Haring that he was going to do a statistical evaluation of his measurement data. Is it thinkable to integrate that into such tools, or is that plainly an offline thing, a real statistical evaluation of all of the measurement data ever incurred of one specific test? So this is something that will have to be done offline. You can't do it until everything has been done, but you can also allow them to grow step by step. That's more the question about a management system, some data cloud, where you have to apply appropriate algorithms. So to begin with, it's independent of test design and hardware. So it's part of the output of the test execution, but doesn't really belong in that. So the report viewer produces a database, or for the report viewer from out of GNU, there is a databank format that is then produced that you could go through along the lines of big data. There's one other question that came to my mind earlier. In all of the tests, it only, in inverted commas, says passed, failed. It never says how good is the go-through and how narrow was the error situation. Is there a way to identify whether it was a massive fail or a narrow fail? Well, the test design states very clearly what you are testing. And of course, I can state certain tolerance levels for the testing. And the other thing that's possible is that I actually record measurement data, and later on, I take a look at the curve, the development of the system, or I can also do some background monitoring. So saying that, check whether the signal never ever crossed a certain threshold. But ultimately, I have to identify for the test beforehand what is still acceptable and when do I consider it to be a fail. So no questions at the moment, but maybe there are going to be some later. So once again, thank you very much indeed for presenting the current and new features. Before we say goodbye, I would like to thank you very much indeed for your attention, and for the rest of the evening, I wish you some enjoyable time. Enjoy yourselves tonight.